Okay, let's dive into lesson 3-5 right triangle applications. So we're going to take what we have learned from lesson 3.1 and we're going to apply this into lesson 3.5, which incorporates it within application problems. So let's review first this problem via a warm-up. In triangle UVW, the measure of angle W equals 90 degrees. Line segment VU is 61, WV is 60, and lastly, line segment UW is 11. What is the ratio that represents the tangent of angle V? So we notice that this is going to be a right triangle given that one of the measures is 90 degrees. So let's go ahead and draw a right triangle, not to scale as far as the length of segments and whatnot. And let's connect these vertices. And we notice that we do have a 90-degree angle as mentioned earlier. So we're going to put that, let's see if I can do that a little more accurately. There we go. Put that little box symbol. We know that W is going to be the 90-degree angle. VU is going to be 61, so that requires us to label the other vertices. So you can either do U to the top and V to the bottom vertex or vice versa. It does not matter. So VU is going to be 61. And then, hold on, let me adjust this here. VU is going to be 61. WV is going to be 60. And UW is going to be 11. Okay, so we start. Now, the first thing you will always do with these type of problems with special right triangles, I want you to get in the habit of labeling what's going on with your sides with respect to the angle that you are standing at, okay? So always label your sides with adjacent, hypotenuse, and opposite, okay? Now, that requires us to make sure we understand where we're standing. From what reference point? So the angle V is where we are going to be standing. And the reason why, that's not what I wanted. The reason why is because it is telling us to find the tangent of angle V. Okay? The tangent of angle V. So here tells us where to stand. And then the next thing you're going to do is label your hypotenuse first. So I'm going to put some yellow highlighting here because within this yellow highlighting, I want to make sure I write and draw attention to those three terms. Hypotenuse is the first thing you will always label. And I'm going to label my hypotenuse here because it is across from the 90-degree angle. Also, 61 is the largest line segment between the three, okay? Now, whenever you are standing at a certain angle, the two sides that make up that angle are always going to be an AH combination. So notice angle V is made up of this side right here, and it's made up of this side right here, okay? Those two sides join at a conjunction to form angle V where you're standing. So I always draw my circle there to draw attention to it so that I can automatically recognize that that side that forms the angle I'm starting out is going to be the A. So AH combination forms the angle where you're standing at. Therefore, the only other missing side is my opposite side. So now that I've labeled everything, I can evaluate the value that I've been asked to evaluate, and that's the angle of tangent V. We know that tangent is opposite over adjacent, okay? Those are the formulas that you need to keep in mind, okay? So the mnemonic we use is the SOH, CAH, and the TOA, okay? So our tangent is the opposite over adjacent. So all I need to do is substitute the opposite length over the adjacent length. And because I was asked to just merely provide a ratio, I'm done. Okay? So 11 over 60 is my answer. Okay? So labeling is so important when it comes to these problems. Okay? So you are going to have angle of elevation and angle of depression mentioned in your problems. And what I want you to understand is that angle of elevation is always going to require you to start measuring your angle from the horizontal. Okay? So I've drawn that horizontal from that man's eyes, showing you that's his normal line of vision, right? But what's going to happen is that sometimes he may look up for a reason. For instance, he sees a plane flying overhead. So that means from the horizontal, his eyesight went up. So that angle that he raised his eyesight, that measurement is called the angle of elevation. Whereas if he's standing on a bridge and he looks downward at passing boats going under the bridge, his gaze has gone down. So therefore, from the horizontal normal line of sight, notice that his line of sight decreases. That's called angle of depression. But it's always measured from a horizontal line, okay? So this is our horizontal line I'm talking about. So keep that in mind when you are doing the next few problems. So I provided some other images here to kind of give you an example. Let's move on to this one. So example 1 has a picture of a giant redwood. The giant redwood tree is casting a shadow of 532 feet long. We need to find the height of the tree if the angle elevation of the sun is 25.7 degrees, and then we are to provide a diagram. So what are we going to do? Well, first of all, simply start with, it helps, especially if story problems intimidate you. Start off with just drawing a right triangle, okay? Because we know that we are in the section of right triangle application problems, so more than likely it has to do something with right triangles. So go ahead and do that. Draw yourself a right triangle to get started. Now, they're telling us that this tree is casting a shadow of 532 feet long, okay? A shadow usually is going to be on the ground, okay? Especially if this tree is standing out in the middle of the forest. So this shadow, more than likely, is going to be represented by this side. So we're going to call that side 532 feet long. They want us to find the height of the tree. So I'm going to let height be represented by the letter H. So I'm going to label this side, which is what I'm imagining the height of the tree to be, H. The angle of elevation. So remember upstairs here in this picture, I'm going to give you the angle of elevation has to start from a horizontal line, okay? Right here that I keep drawing. And the angle of elevation of your eyesight will go upwards. That's angle of elevation. So notice our horizontal line is the shadow, and the angle of elevation of the sun is 25.7. So that just merely means if you're standing right here, for example, there's a sun possibly, over here shining off to the tree, and you're gazing upwards, okay? So originally your line of sight was this right here. You're looking forward that way, and then all of a sudden your line of sight went whoop and looked up, okay? That's what's happening. So angle of elevation goes from here to here, and that is going to be 25.7 degrees. So now we used up all the information. Yep, we've used up all the information in our story problem here. So now it's time to analyze and label our sides, okay? So first you decorate your right triangle with the given information, okay? They will give you always 2 givens, and they ask you to find 1 missing. And here's why, okay? So before I even start into the problem, I'm going to digress for a second. Here's what I want you to notice. We have 3 formulas. The sine of an angle in degrees will always be opposite over hypotenuse, okay? Then, let me erase this mark here. Then we have cosine of an angle would be adjacent over hypotenuse. And lastly, we would have tangent of an angle equals opposite over adjacent. All right, those are the three things we've got. So what you want to do is notice that there are going to be two things given to you and one thing needs to be looked for. So I'm going to do some highlighting here to pretend and give you an example of what I mean by that. Okay, so for instance, on a picture, I might give you this angle in sine and this opposite side, and I'm going to ask you to go look for hypotenuse. And that would be the question mark. Or I might say, you know what? I'm actually going to give her the adjacent. I'm also going to give her the hypotenuse. And I want the student to look for the cosine angle. I want them to find the angle. Or last type of thing, I might give you an angle. I may not give you the numerator value of something, but I'm asking you to find instead the adjacent. So there's many combinations, okay? I will give you two things, which I've highlighted in yellow, and I'm going to ask you to look for the missing thing. You just have to decide which equation you're going to use, okay? That's basically how you do these problems. So let's proceed in doing that, okay? So I'm going to erase this for a second. So if you need this, go ahead and pause the video, copy these down somewhere, because I'm going to erase them. Okay, so let me erase now. So which equation are we going to use? Well, first of all, let's talk about where we're standing. We're standing right, whoa, that's really too big. I don't seem to have a good hand on how to use this circle button. So I'm standing right here, okay? Now, determine where you're standing, always draw where you're standing. The next thing you are going to do is label your sides. And you know how I like to label my sides, so I'm going to put my highlighter in these areas because this is what I want to draw my attention to, okay? Start off with labeling your hypotenuse. So hypotenuse is right here, okay? There's my hypotenuse. The next thing I'm going to label is my A. And the reason I choose my A is because I know where I'm standing, it's always formed by the letters A and H. So therefore, this right here, let me draw this, has to be my A. Okay, because where I'm standing is formed by this side and by this side. This side here left over is my O. So, what do I notice? I notice that I have to use the H, okay, because that's what I'm looking for. I'm going to put the word find. Okay, there's three things that you need to highlight. Two givens, one find. So I need to find my opposite side, which is the hypotenuse. I've been given the 532, so I have to use that. And I've been given the angle, okay, which is the 25.7. So if I have to use the H, which is an O, and I have to use the A, which is a given, OA combination, remember, these are the ones that we need to remember. The OA combination is my tangent formula. So I need to write the formula for tangent. Tangent of a blank degree will always equal to O divided by my A. Okay, so now I'm going to fill in those blanks. Tangent, am I given an angle? Yes, it's 25.7 degrees. Equals, am I given an opposite length? No, that is my H that I'm looking for. The H is with my O. Am I given with an adjacent length? Yes, 532. So what am I going to do now? I am going to multiply both sides by 532 because it's dividing. So 532 times the tangent of 25.7 degrees is going to be my h. Make sure that you put your calculator in degree mode, okay? Press mode on your calculator and make sure you put it in degrees. Now, I'm going to type that in the calculator and I'm going to get an answer. And I'm going to say, let's round to 2 decimal places. Okay, so now let's round and we end up getting 256.03 feet as our final answer. And round to 2 decimal places. Okay? So there's the height of the redwood tree. All right, let's try this again, okay? So moving on to the next one. So let's get started. From the top of a 200-foot lighthouse, the angle of depression to the ship in an ocean is 23 degrees. How far is the ship from the base of the lighthouse? Provide a diagram. Okay, so again, let us attempt to decorate our right triangle. And so again, I am going to, did not mean to do that. I'm going to draw a right triangle. I'm gonna label our squared side to depict the 90. And let's see. The first thing is they're telling us that this lighthouse is 200 feet. And from the top of this lighthouse, right, so you spot a boat. Okay, so I'm going to pretend we're over here at the top of the lighthouse and we spot a boat. Okay, and here's the boat. Way over here, a very poorly drawn boat. And you know what, let's have some fun and provide some water. Okay, so here is our boat. Now, your line of sight, remember, your line of sight from the top of this lighthouse is usually like this, okay? Remember that. But you are spotting a boat, and they say the angle of depression to the ship that's in the ocean ends up being 23 degrees. So that means from the horizontal, because you remember I told you it always has to be from the horizontal, you're going to look at the angle in a downward motion. Let me try that again. Okay, so that is 23 degrees. Okay, 23 degrees. Alrighty. Now, because that's 23 degrees and that's 200 and, we still need to determine how far is the ship from the base of the lighthouse. Well, base of the lighthouse means the bottom of the lighthouse where it makes contact with the ground. So they're asking us to find this distance right here. So we need to pick a variable to represent how far. So I'm going to use the letter F, okay? Letter F, looking for how far we're looking for. The base of the lighthouse to the ship. Now, what do we do next? So we decide to stipulate where we're standing, right? Well, we're standing right here, okay, at the top of the tower. And remember, you have to determine where you're standing so that you can label your sides. So let's go label some sides here. Let's use red on this one. So always start with your hypotenuse. So I'm going to put my little yellow highlighters and I'm going to start with my hypotenuse. My hypotenuse is always across from the 90. There we go. I'm going to put a box here to draw attention to it. My adjacent is always the one that connects with the hypotenuse to form the angle where I'm standing at. So adjacent has to be this one right here. Again, trying to prove to you guys this and this right here is the angle where I'm standing. So wherever I'm standing, those two segments are the A and the H. And therefore, the leftover is always going to be my O, the opposite side. So I have everything labeled. Now I'm going to tell myself, okay, I need to decide, am I using the sine, the tangent, the cosine? I don't know which one I'm using. Well, first of all, which one are my givens? So my givens were this one. This was given to me. So I have to use A. Okay, I have to use A. So I'm going to put a black thing around it. I have to use A. What else was given? My angle was given. Angle was given. So that's not really helping me right now. It helps me in the process of elimination, but I need one other letter to help me determine what trig function I'm using. Well, I have to find F. That's what I'm looking for. So that means I have to use O. So which trig function uses O and A? Well, we just did number one, used O and A. Well, again, we're using this one. And no, it's not always going to be tangent. It just so happens that the two first problems ended up being tangent. Okay? So here's our formula. Write out your formula and then start substituting what you know goes in what spot. So you ask yourself, do I have an angle? I do. You're going to want to put 23 degrees, okay? But actually, that's not correct. So I'm going to leave that 23 degrees there so you would remember that I said, nope, that's not correct. Because no, look at where your angle 23 is. It's on the outside of your triangle. Therefore, you need this angle right here, okay? Now, we know that this angle has to be complementary with 23. In other words, it has to form a 90-degree angle. I'm going to draw a little square here because I want you to notice this here is a square, okay, with the horizontal and the side of the triangle. That means that that 23 has to add with another number to make 90, and that number is 67. So this here, this angle right here, is actually 67 degrees, the one inside the triangle. So actually we're going to use tangent of 67 degrees is equal to, do I have an opposite? Nope, that's what I'm looking for. That's my F. Do I have an adjacent? Yep, there's the 200 that was right next to it. So in order for me to solve for F, I needed to multiply both sides by 200. Okay, I need to multiply both sides by 200. So 200, the tangent of 67 is going to equal my F. So let the calculator do all the work. Type that out in the calculator. Again, reminding you that you must make sure your calculator is in degree mode. And we are going to choose to round to 2 decimal places. And there we go. 471.17 feet is the length of the distance from the base of the lighthouse to the boat. Okay, let's try it again. Second to last problem. A 40-foot ladder leans against a building. If the base of the ladder is 6 feet from the base of the building, what is the angle formed by the ladder and the building? Okay, so this should be redundant. Yep, we are going to draw a triangle. And there it is. And I'm going to establish that this is the corner that is 90 degrees. Okay, so we have this ladder leaning against the building. So in this particular problem, I want us to imagine that the building is this vertical line. Okay, so here's my building. All right, this is the building. And this ladder is leaning against this hard surface. So the ladder is going to be, this right here. I'll go ahead and write it in just a bit. Okay, so the ladder is leaning against this building, okay? And they're telling us that this ladder is 40 feet long. So I'm going to write in that this is 40 feet long. And they are telling us that the base of the ladder is 6 feet from the base of the building. So right here, that part is 6. And then they're saying, hey, do us the favor and find the angle formed by the ladder and the building. So the angle formed by the ladder and the building would just be this, wouldn't it? I mean, here's the ladder, here's the building. So it's definitely not this one because this is the ladder and the ground. And we know this is the building and the ground, and we never stand at 90. So we are focusing on the top. So I'm going to make a mark here like this. And we are looking for that angle, and we're going to call it theta. Okay? It looks like this. It's just like an O with a line through it, and it's a Greek symbol, and we use it a lot to represent the missing angles. Okay, so that's theta. Okay, so let's label. All right, let's decorate a bit more. So we know we're standing right here, right? We're standing right there, and we've climbed up the ladder, by the way. We've already climbed up the ladder. And they want us to find that angle. We need to label the hypotenuse, the adjacent, and the opposite. Okay? So our hypotenuse is always across from the 90, so that was easy enough. We know this time this side here is going to be the A. Okay, why? Because this and this is where I'm standing, and those will always be the A and H of our problem, okay? This is going to be our O. And now, what do we do next? I'm hoping you're answering this by this point. We are going to focus on what is our given information and our find information. So I noticed that I've been given a 40, so I'm going to put this as given. I've been given a line segment of 6, and I'm being asked to find an angle. Okay, so looking at what has been given to us, does that help determine what our trig function is going to be? Well, it does. Our given here was this one, the green, an H, and an O. And we look at our trig functions to see which ones are H and O, and we find out that it is our sine function. The sine of a blank angle will always equal the side opposite over the hypotenuse side. The O and the H, which were given to us. So let's substitute. So we've got sine of my angle. I don't have an angle. And for angle, we are using the symbol of theta. Oh my goodness, I can't get my screen. The symbol of theta equals my opposite is a 6, my H is a 40, okay? So this one's a little bit different to problem number 1 and number 2. Hopefully you're noticing that. Notice with problem number 1 and 2, you were asked to find a distance, a missing side length. But now you are missing an angle, okay? We are now looking for an angle. That's what we're looking for. So how do we isolate theta? We need to get theta all by itself, okay? That means we have to get rid of this. I can't exactly do this and just erase sine to get theta by itself. It's not that easy. You can't just do that on an equation. You have to undo the function, so to speak. So how do we do that? Well, what's going to happen is I need to move sine over to the other side. And what I mean by that is that when you are solving for an angle to isolate it, the trig function that angle is accompanied by is going to move over to the other side and become what's called an arcsine or a sine inverse. Okay? An arcsine or a sine inverse. So sometimes you will even see it like this. Instead of sine inverse, they write it like this. Arcsine. Both way are the same. Okay? So the sine becomes a sine inverse, and then you just bring down the number that was already on that side of the equal sign. And you are going to type that out in your calculator because you're done. You already solved for theta. And let's round to the nearest hundredth place again. And you would end up with 8.63 degrees. And you are done. Okay? So moving a sine over to the other side just causes it to become an inverse. Okay? That's it. For instance, I am going to write, let me see here. Let me go over here for a second. For instance, if you have, I'm going to make up some problems here, like tan inverse, not tan inverse, my bad. Let's say it was tangent theta of 3/7. You would say theta equals tan inverse of 3/7. The tan moves over to this side. Or if you had the cosine theta equals 2/5. Well, the cosine will move over, and you'd say theta equals cosine inverse of 2/5. Okay? So it just becomes an inverse on the other side. Okay, last one. Let us go down a giant straight water slide that is 175 feet above ground. It's 200 feet long. What is the angle of depression to the bottom of the slide? Provide a diagram. Okay, so another scenario of a 90-degree triangle. Let's get that square drawn in. Okay, so you have this giant water slide, okay? It starts way up, so I'm going to put water slide here. And you are at the top of this water slide, getting ready to come on down. And they say that this water slide is 175 feet above the ground. So I'm going to label, 175 feet. So you just went up to the top of this water slide, and you're about to come down. They also said that the water slide is 200 feet long. And the angle of depression to the bottom of the slide is going to be what? Again, you are up here standing at this top of this slide. Let me put this a little bit better. Okay. And you have a line of sight. Again, here's that line of sight that we're talking about. And it's not really, okay, you know what I'm talking about. There's your line of sight, and they are telling you they need you to find the angle of depression. So the angle of depression would be this angle on the outside of your triangle, okay? Now the key is, if we want to find that angle of depression, I'm going to put theta there. Okay, theta is what we're looking for. We need to actually, I'm going to erase this water slide because I'm not going to have enough space. We're going to need to find the angle of the inside of that triangle, all right? We need to actually find that inside one. So in order to be able to do that, we need to use trig. So I'm going to label that we need to look for this first, because we know that this and that angle of depression on the outside add to 90. So I'm going to call this x degrees. We're looking for this angle. Okay, so we know we're standing right here. Okay, we know we're standing right there. We know we need to label OA and H. right? So I'm going to do my little yellow highlighting again. I always start with my H, which would be this, outside of the 90. My A has to be this because of where I am standing, right? Again, shading this and this is where I'm standing. So those two sides have to be A and H. That's why I labeled them A and H. So this one has to be my O. It's too far away from me. The furthest side away from me will always be the O. It's always across from me. O is always across from where I'm standing. Okay, so I need to find out what was given. I always get two givens and look for one find. So I need to find my angle. So I know that. So I'm going to find an angle. I am given a hypotenuse. And I'm given an adjacent. And I know that my AH combination, based on my SOHCAHTOA, is my cosine. Cosine blank degrees equals A over H. So I am going to substitute the cosine of my angle, which we called it X, is going to equal the A value, which was 175, the H value, which is 200. And just like I showed you earlier, we're going to solve for X by taking cosine and making it an inverse of the ratio. And then once you type that away in your calculator and round to 2 decimal places again, it will be 28.96 degrees. But that wasn't what we were looking for. We were looking for theta, green theta. And we know that those two angles have to add up to 90. So I'm going to take 90 and subtract 28.96 from it. And that will help me find the angle of depression. This is the angle that I had to look down from my horizontal. I bent down, my chin dropped 61.04 degrees in order for me to see the bottom of this slide. Okay? So I'm way up at the top of this water slide. I was looking straight out, and then I dropped my line of sight, my gaze downward 61 degrees to be able to see where my landing pad was going to be. So that's it, my dears. That is lesson 3.5. Hope this note lesson helps you understand how you need to approach these problems. Remember, again, you draw the triangle, decorate the triangle, and then get ready to label your A, O, and H based on how you decorated. But you have to determine where you are standing first. So circle the corner that you are standing at. It will always be one of the acute angles. Circle that corner, label A, and H. And remember, there's always 2 givens, 1 find. And that will help you determine whether or not you're going to use sine, cosine, or tangent. Thanks for watching, and good luck on your assignment. And as usual, if you have any questions, give Hanlon a ring, not a ring, a text. Thanks for watching. Bye.